Okay, so we are moving on with our discussion on graphing. And what we're going to do today is we're going to focus in on a particular aspect of graphing. One of the things it's used for, one of the things that's useful for, and that's to help us analyze patterns. So utilizing tables and utilizing graphs are a great way for us to organize the data that we're dealing with, whether it's in a science project or a math problem or whatever. And so that's what we're going to focus on in this video is how to use tables and graphs to organize data. In the next video, we'll then take that one step further, and based on the information that's in a table or information that's in a graph, we'll try and convert that into an equation that we can use to do other types of mathematics. Okay, so this is kind of a bridge discussion. And so we're going to be very tangible in this. We're going to look at some physical objects and look at some actual physical patterns and then try to describe them with tables and graphs. In this, there's going to be some important key ideas and concepts that theoretically you already know, but perhaps depending on how you were taught this back in middle school or in your last algebra class, we might be presenting it, or I might be approaching it. There's the word I'm looking for. We might be approaching it from a different sort of perspective. So as you're watching the video, as you're taking your notes, think back to what you already know about graphs and tables and things of that sort, and see if you can start making the connections and see if you can tell where it is that we're going with this. All right. So with that said, let's take a look at the learning objectives for this particular video. The learning objectives will give us a hint about the kinds of things that we're going to talk about. So the first thing is just the actual process of how to take data and turn it into a table or to turn it into a graph. Okay, so that's the first thing. Fairly straightforward, something that you've done before in other classes. Okay, but as we do that, I'm going to introduce some terms here. And the terms that we're going to introduce, you can see there's kind of a lot of them. In this particular video, we're not going to actually write down a definition for any of these terms, but we are going to start talking about them. We are going to start using them. And I'm going to expect you to start becoming familiar with them. So notice it doesn't say defined or anything, but just be familiar. That's the learning objective. So pattern, rate of change, slope, initial value, step 0, y-intercept. Okay, so these are terms that we will use throughout the rest of our graphing process. And so you're going to want to be familiar with them. Okay, so I said that we're going to do this with physical objects. So hopefully moving the camera doesn't make you motion sick or anything. I have some physical objects here. All right, so what I have is, you can see 4 Lego blocks that have been arranged. For our discussion, for what we're going to do, we're going to simply keep track of how many Lego blocks there are, and we're going to look at for a pattern in the number of Lego blocks. The colors don't mean anything. The shape isn't even really important, although the shape is going to help us to recognize how many blocks there are. But really what we're focusing on are the number of blocks. So in this case, what you can see is I have 4 blocks, 1, 2, 3, 4, and this is the very first shape that we're going to start with. Okay, so to help us organize this, I'm going to begin with a table, and this is an expanded table. So normally when we look at tables, we just have X's and Y's, and that's all we have. But you can see in this table, I've expanded out, I've added a couple extra columns. So just so that you're kind of prepared for where we're going to go. The information that's in this first column is what we're going to end up graphing on our x-axis eventually. Okay, now we're a long ways away from that. But by the time we get to the end of the video, these are numbers that are going to go on my x-axis. And the number of blocks that are in our shape, that's what we're going to graph on our x-axis eventually, a long time from now. Okay, but I've got some extra stuff in the middle here that I want to make sure that we realize exactly what it is that's kind of going on as far as the way the pattern is building out. In other words, I don't want us to just simply count the number of steps and simply count the number of blocks. I want us to see mathematically how this number is becoming this number. And that's what I kind of want to start to focus on as we do this. All right. So in our first shape here, again, you can see we've got 1 block in the middle, and then there's 3 blocks going out from that. Okay. And so what we're going to do with each different progression is we're going to add 3 more blocks. Again, the colors don't matter, so you can ignore the colors. But coming off of each one of these little spokes or little extensions here, I'm going to add 1 more block on each side. So I've added a total of 3 more blocks. Okay. So the first one that we had just had those 4. And now the second one that we have has 7. So in my table, I've recorded that information for those 2 steps, okay? So in the first step that I had, the first shape that I had, whatever you want to, step, shape, whatever, in the first one that I had, there was the block in the middle, and then there are 3 blocks coming off of each side. And that gave me a total of 4 blocks. Then in the next one, the one that I just built, there was the original one in the middle. There were the original 3 coming off the sides, but then I added 1 more to each side. So I added 3 more blocks altogether, and that gave me 7. Okay, now I'm going to explain this in just a second. Let me do one more shape first, and then I'll come back and I'll explain what's happening in this column. All right, so we're following that exact same pattern. So I've got a couple more Lego blocks here. 1 more coming off in each direction. There we go. Okay, so now I've added 3 more blocks. So there were 7, I added 8, 9, 10 is what I have for my total number of blocks now. So coming back to my table, there was the original block and the 3 sticking off of it, the original block in the middle and the 3 sticking off. There were the 3 that I added on this step, and now I've added 3 more. And that adds up to 4, 7, 10 blocks altogether. Okay, so this is the basic idea of what we're doing. Now let's talk about what's happening in this column for a second. You can see I've labeled this column rewriting with multiplication. And the reason why I'm labeling that is because notice what's happening here is every one of these has the original 1 block that's in the center of the shape. And then there's the 3 blocks that are coming off of the spokes. And with each subsequent step, I'm adding 3 more blocks, 1 to the end of each spoke. And so what happens is I get 1 3 right here, and then I have 2 3s on the next step. And then on the next step, I have 3 3s. And you can probably predict on this next step, I'm going to have all of the blocks that were already there. And then I'm going to add 1 more block to the end of each spoke. And since there's 3 spokes, that means I'm going to add 3 more blocks. And so that means I'm going to end up with 5 3s. Okay. Now, if you think back to elementary school, at one point or another, you learned that multiplication is just repeated addition. So if I have 3 3s, I'm sorry, right here, 3 3s, that's the same as having 3 times 3. If I have 2 3s, that's the same as having 3 times 2. If I have 4 3s, that's going to be the same as having 3 times 4. And so I've got these original ones at the beginning that are just sitting there. But then the 3s, I'm rewriting those as being a multiply problem. I'm rewriting those as being a multiply problem. Okay, whoops, this has 4 3s. 1, 2, 3, 4. This has 4. There we go. All right, so that's all I'm doing with this table. So let's see, 3 times 4 gives me 12. 12 plus 1 gives me 13. If I had 10 before and I added 3 more on, I should end up with 13. If I go back to my shape and I count my shape, okay, so here were my original 4 from step 1. Here are the 7 from step 2. Here are the 10 from step 3. Now on step 4, we said we're going to add 3 more. Do I end up with 13? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sure enough. Okay. So the idea here is I want to make sure that I can recognize what's happening with patterns mathematically and connect that back to what's happening with the pattern physically. Okay. So physically, what's happening is I'm just simply adding 3 blocks to each shape. That's what's happening physically. So add 1, 2, and 3. Okay, so that's what physically is changing. That's my pattern physically. Mathematically, I can describe that pattern lots of different ways. I can describe that using addition. There's all the stuff that was originally there, and then I added on 3 more blocks. That's literally what addition means, right? Is that we're adding on to our shape, adding on 3 more blocks. By definition, repeated addition is multiplication. So I can say that what I've done is I've now multiplied 3 times 5. And I could write the pattern that way. Or I can just count up the total number of blocks. If I counted them all up, I'd have 16 altogether. And what I'd like you to notice is notice that with the exception of this, where we're just keeping track of what shape we're on, so that was shape number 5, these three things are all equal, right? 1 plus 3 plus 3 plus 3 plus 3. This is equal to that. And that is equal to this. And so notice what this does is it connects the idea of being on the 5th shape, right? Because now we've got 5 of those. And then it takes that and it connects it mathematically to an equation. Actually, I guess an expression, right? Because there was no equal sign. And it connects that expression mathematically to the total number of blocks. Okay, and so that's really what we've got going on here. So hopefully, if you kind of are getting the sort of the intuitive idea of this, then you should be able to fill in this next line right here. If I do this for another block, so this will be shape number 6. Pause the video and jot down on your paper what will go into these 3 blocks right here. All right, so hopefully you've written that down. If you've followed the pattern here, the pattern is that we have all of the stuff that was there before. So 1, 2, 3, 4, 5 threes, 1, 2, 3, 4, 5 threes. And then we're adding on 3 more. That's our pattern. So we should have a total of 6 threes there altogether. Now over here, you could say that by definition, if there's 6 threes, that means I'm doing 3 times 6. But also know that this is a pattern here, right? Every one of these has a 1 plus, whoops, 1 plus, and then 3 times something in 1, 2, 3, 4, 5. So times 6. That would be my pattern that's going down here. Okay. And then this also has a pattern. 4 plus 3 equals 7. 7 plus 3 equals 10. 10 plus 3 equals 13. That gives me 16. So if I add 3 again, I should get 19. So the next thing I want to make sure that you notice is that there is a pattern as I move across each row, but there are also patterns as I move down each column. Okay. And so that's another thing to make sure that we recognize. All right. Now, here's what I'm going to do is I'm going to ask you to extend this out for a second. So I'm going to say, let's pretend for just a minute that we've already done step 6, 7, 8, 9, and we're on step 10. Can you guess, can you predict what's going to go into this table for step 10? Hopefully you've written down a guess. Hopefully you've taken the time to find a guess. If you haven't, pause the video and do that now. But if you've guessed, what we should have in this first thing is we should have a total of 1 plus 10 threes altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 threes altogether. Here we should have 1 plus 3 times 10. And then over here, well, I could figure out the pattern by adding on to 19, or I could just simplify one of these and find the pattern. Looks like we should get 31. But let's verify, right? If this was 6, then plus 3 would give me 21 at 7 for step 7. Plus 3 would give me 24 at step 8. Plus 3 would give me 27 at step 9. And then plus 3 more would give me 30. Wait, I'm off by 1. Oh, I did the very first one. I was wrong. Did you catch my arithmetic mistake? 19 plus 3 doesn't equal 21. 19 plus 3 equals 22. So step 7 would be 22. Plus 3 more would be 25 for step 8. Plus 3 more would be 28 for step 9. Plus 3 more would give me 31 for step 10. And that matches with what these are giving me. So that seems to work. And of course, we can always come back over here and we can verify that with our blocks, right? So there was our step 1. Here was step 2, step 3, step 4, step 5. So step 6 will be these 3 blocks right here. There's our step 6. Step 7 will be these 3 blocks. There's our step 7. Step 8 are these 3 blocks. Oh, I'm running out of room here. And then I have step 9. and step 10. And I've officially run out of room. So I guess this is as big of a number as we're going to get to. But there's my step 10. So let me zoom out so you can see all of my blocks. Let's count them up to make sure that it is the right answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 31. So that works. So we've got it in blocks and we've got in the table and everything is good and fine and wonderful. Okay, so this is the basic idea of using the table to describe a pattern that we have in the blocks. Right? So what we want to do now is we want to start talking about, let's convert this into a graph. Right? So I've got the same graph paper that I used yesterday for our notes in the last video. I'm going to have to, hopefully, let's make sure this is going high enough. So if this is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, I'm going to need a different piece of graph paper. This one isn't going to be big enough. All right, so let me grab a fresh piece. Here we go, fresh piece of graph paper. And I'm going to put my origin way down here in the bottom because we need enough room to be able to graph 31 blocks here. Okay, so I'm going to put my origin way down here. All right. All right, so there's my graph paper. So there's 0, 0, so this would be -1, and this down here would be -1. But of course, we're not going to have negative blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is as far as we went. And going up 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 25, 6, 7, 8, 9, 30, and there would be our 31 will be up there. Okay, so now we're ready to draw this graph here. Now we're ready to draw this graph. So remember what we said is the step number or the shape number. This is going to be what we're going to graph on our x-axis. The y-axis is going to be the number of blocks. So our x-axis is the shape number or the step number, whatever you want to call it. And the y-axis is the number of blocks that was in the shape. Okay, so here we go. Let's take a look at the graph. So the first one we had was step 1 had 4 blocks. So that's the point 1, 4. So 1, 4. There's our first one. Okay, step 2 had 7 blocks. So that's 2, 7. Step 3 had 10 blocks, so that's 3, 10. Step 4 had 13 blocks, so 4, 10, 11, 12, 13. Step 5 had 16 blocks, so there's 15, 16. Step 6 had 19 blocks, so that's oops, there we go, there's that. And then last step 10 had 31 blocks. So here's step 10, had 31 blocks right there. Okay, so hopefully right away you should immediately see that there's a definite pattern to this, right? If I connect these dots, what am I getting? They all just happen to be in a straight line. Okay, if you remember from geometry class, we called that collinear, right? They all lie on the same line. So one thing that we might talk about in an algebra class is I wonder what the equation of that line is. Okay, that's something we're going to talk about in the next video. That's going to be tomorrow's topic. What is the equation of that line? Okay, so stay tuned, watch tomorrow's video. We'll get the answer to that question then. In fact, we're going to come right back to this exact same line to help us figure out the answer of that tomorrow. Okay, but in this video, what we're going to talk about is let's use this pattern to extrapolate out to other information. So with this table, we were able to use patterns to figure out what 10 would be, and then we checked it with the blocks, but we used the patterns to figure this out. Okay, I could just as easily use patterns to figure out things like, all right, so what about how many blocks were in step 7, right? So in step 7, looks like there should have been right here 22 blocks in step 7. Okay, and so we could grab the blocks and we could check that if we wanted to. We're not going to, but we could. Okay, but remember, lines go forever. So I could also use this pattern to figure out, so how many are going to be in step 12? And I could come up here to step 12, and I could figure out where this line is going to cross. Okay, and I could find that. But I also want you to notice that the fact that it's a line means there's another very definite pattern. Did you notice that every time we went 1 over to the next step, this number went up by 3. Every time we went 1 step over, the number of blocks went up by 3, right? We recognize this. This goes up by 1 every time. This goes up by 3 every time. So in our graph, notice it's going up by 1 in my step number, and that caused me to go up by 3 in the number of blocks. So I'm going over 1 and I'm going up 3 every single time, to the right 1 and then up 3 every single time. So this 3 that we're seeing in the pattern here shows up in the pattern over here as well. Okay, so that's another thing that's interesting. Now, here's the last thing that I want to mention just from our graph, that the graph and the table both help us to recognize. Okay, let's go back to our blocks here for just a second, and let's go all the way back to the original shape that we had. Okay, right here. There's our original shape. All right, so let's just zoom right in on that. There's our original shape. This is where we started. Okay, that's what began this whole discussion right here. Now, we called that step 1 because that's where we started in this video. That was the first thing that we looked at. That was shape number 1. But what if I told you that before I started the video, somebody came along and made that shape? Well, that wouldn't surprise you, right? But think about how they made that shape. There's a block in the middle with 3 blocks around it. See how they've used the exact same pattern that we were using to build all our shapes? There's a block in the middle. There's 3 blocks around it. So I could theoretically go backwards to deduce what was the step before this one. How would I deduce that? Well, if our pattern was we added 3 blocks on every single time, then to go backwards to figure out how many blocks there were, I could pop 3 blocks off. And this is what we had before step 1. Okay, you might call this perhaps step 0. So in my table, well, notice I've left a space up before step 1. I don't know, maybe if you saw that before, if you were wondering, why is there a space before step 1? Well, because things come before 1. Something comes before 1. And what we just saw is that step had 1 block in it. But I want you to notice that all of these patterns still work. If I'm adding on 3s here, if I just take this 3 off, there's how many blocks I have. If I'm multiplying 3 by however many 3s there are, well, I have 0 3s. So doesn't that mean I have 3 times 0? And notice that all of these patterns still work. Even right here, is the pattern still going up by 3? Or if we want to think of it as going backwards, did I go down by 3? Okay, do we see that this is changing by 3? It is, right? That pattern holds true in all of those places. And it also holds true on the graph. On this graph, I can say, well, look at, here was my initial step. But if I want to go back to figure out what came before, this was step 1, I guess we could say. The initial step, if I follow the same pattern of over 3, up 3, so now I'm going down 3, back 1, notice I end up at exactly 1. Okay, so all of those patterns hold true. And the numbers that we're using here all become significant. And these are numbers that maybe you already, or names for the numbers that maybe you already know. And so I want to revisit our vocabulary. Okay, I want you to notice that I've talked about a pattern in this. The pattern was that we were adding on 3 with every step. We added on 3 with every step. Okay, that was our pattern. Okay. Now, notice though that that's describing the change, right? That's describing the change. If somebody said, how are these numbers changing? You would say, well, they're going up by 3 every time. That's how they're changing. So this pattern is also called a rate of change. How fast is it changing? It's changing 3 blocks per step. That's how it's changing, 3 blocks per step. So that's a rate of change. So pattern and rate of change, they mean the same thing. They mean the same thing. But if you were paying attention over here, this go over 1, go up 3, that should sound very familiar from one of your other algebra classes. When we talk about how far up do you go compared to how far over you go, sometimes we use the words like what is the rise and what is the run, right? How far over, how far up, the rise and the run. You might remember that as being called slope. So we go up 3 and right 1. So notice these are all saying the same thing. Add 3 blocks, up 3. And then for what? Per each step, per 1 step. Okay, so they're all giving us the same basic ratio of 3 to 1. And that ratio is what we call the pattern and the rate of change and the slope. You see, all 3 of these things, these are all the same thing. They're just different names for the same idea. How does the line change? And you might be able to guess that's also true for these, right? These are also 3 different words for the same thing. Not the same as these, but the same thing, okay? So what have I got? We said that if this was step 1, going backwards gave us step 0. And that's how we labeled it on our table. We called it step 0. But that's also known as the initial value. Okay. A lot of times in story problems, we'll see that there's an initial value that you begin with. That is your step 0. Okay. And you might remember from graphing that because this is always going to be the spot where we're crossing the y-axis. So it's also called the y-intercept, where we touched an axis as an intercept. So there's the y-intercept. Okay. So that is a very basic stuff. Like I said, hopefully there was nothing here that you felt like was earth-shattering. But the idea here is we want to be able to take these math terms that we're going to see over and over and over and over again all year long. And we want to be able to connect them both to graphs and to tables and to physical objects in the real world. Right. And so we want to make sure that these words are all describing something tangible, but we can organize these with tables and graphs to make it a little bit more abstract and make it easier to see what those patterns and things are. Okay. And that's something that we're going to leverage in the next video when we start making equations, when we start making equations. All right. So that's it for this video. Thanks for watching. Thanks for having the patience to work through that with me. Well, so just thanks for watching. Have a good one.